What is the use of join in Python threading? I was studying the Python threading and came across join. The author told that if thread is in daemon mode, then I need to use join so that thread can finish itself before main thread terminates. But I have also seen him using t.join even though t was not daemon. The example code is this. I don't know what is use of t.join as it is not daemon and I can see no change even if I remove it.
A somewhat clumsy ASCII art to demonstrate the mechanism. The join is presumably called by the main thread. It could also be called by another thread, but would needlessly complicate the diagram. Join calling should be placed in the track of the main thread, but to express thread relation and keep it as simple as possible, I choose to place it in the child thread instead. So the reason you don't see any changes is because your main thread does nothing after your join. You could say join is only relevant for the execution flow of the main thread. If, for example, you want to concurrently download a bunch of pages to concatenate them into a single large page, you may start concurrent downloads using threads, but need to wait until the last page/thread is finished before you start assembling a single page out of many. That's when you use join.
Straight from the docs. Join, timeout, wait until the thread terminates. This blocks the calling thread until the thread whose join method is called terminates, either normally or through an unhandled exception, or until the optional timeout occurs. This means that the main thread which spawns T and D waits for T to finish until it finishes. Depending on the logic your program employs, you may want to wait until a thread finishes before your main thread continues. Also from the docs. A thread can be flagged as a daemon thread. The significance of this flag is that the entire Python program exits when only daemon threads are left. A simple example, say we have this, which finishes with this will output. Here the master thread explicitly waits for the T thread to finish until it calls print the second time. Alternatively, if we had this, we'll get this output. Here we do our job in the main thread and then we wait for the T thread to finish. In this case we might even remove the explicit joining t.join and the program will implicitly wait for T to finish.
Thanks for this thread, it helped me a lot too. I learned something about join today. These threads run in parallel. And these run sequentially, not what I wanted. In particular, I was trying to clever and tidy. This works. But it runs sequentially. I can put the self.start and underscore init underscore, but not the self.join. That has to be done after every thread has been started. Join is what causes the main thread to wait for your thread to finish. Otherwise, your thread runs all by itself. So one way to think of join as a hold on the main thread. It sort of threads your thread and executes sequentially in the main thread, before the main thread can continue. It assures that your thread is complete before the main thread moves forward. Note that this means it's okay if your thread is already finished before you call the join. The main thread is simply released immediately when join is called. In fact, it just now occurs to me that the main thread waits at d.join until thread d finishes before it moves on to t.join. In fact, to be very clear, consider this code. It produces this output. Note how the print statements are threaded into each other. The T1.join is holding up the main thread. All three threads complete before the T1.join finishes and the main thread moves on to execute the print, then T2.join, then print, then T3.join, then print. Corrections welcome. I'm also new to threading. Note, in case you're interested, I'm writing code for a drink bot, and I need threading to run the ingredient pumps concurrently rather than sequentially. Less time to wait for each drink.
The method join blocks the calling thread until the thread whose join method is called is terminated. Source: this URL.
If you want to see more, please consider subscribing.